Hi, everyone. We're going to go ahead and get started this afternoon or morning, depending on what time zone you're in. Thanks for joining. Before I hand it over to Jim, I just want to quickly introduce Viscosity. So we are a solution-based consulting company. We specialize in data management-based technologies. We're also an Oracle Platinum partner. We've got genuine Oracle experts. We now have 5 Oracle ACE directors with us, one of which is Jim Czuprysnki, who I'll introduce in a moment. We've also published more than 23 books in the Oracle space, ranging from performance tuning to Oracle Cloud. And we have 3 focus pillars: data, applications, and infrastructure. In the application space, we run the full stack ranging from EBS, PeopleSoft, JD Edwards, as well as SaaS to PaaS integration. Data, we focus on everything from database to data integration and analytics. And then infrastructure, our focus ranges from public cloud, private cloud, and engineered systems. And then this is a brief portfolio of what we do within those 3 pillars. So everything from zero downtime migrations, license management, assessments, to turnkey projects. And then this is our speaker for today, Jim Czuprysnki. He actually just joined Viscosity a couple months ago as a senior data architect. I mentioned earlier, Jim is also an Oracle ACE director. He's got almost 4 decades of IT experience serving different roles at several Fortune 1000 companies. He's also co-authored 4 books and even has a blog. It's called Generally It Depends, and it contains his thoughts on all things Oracle. He's also an amazing speaker. He's a regular throughout Oracle user groups in North America. His next one, I believe, is in Chicago next week. And with that, during the webinar, if you've got any questions, feel free to email us at hello@viscosityna.com, or you can use the chat feature on your screen and we'll get back to you. And with that, I will turn it over to Jim.
Well, thanks, Morgan. You saved me a whole slide right there. Let me grab the screen. And folks, if you were at our last webinar, we had a bit of a technical handout issue, but not today. At least that's what I said 5 minutes ago. Hopefully that's looking fine. Morgan?
Yes, that's perfect.
Good. Okay. So let's go ahead and get started. So as Morgan said, my name's Jim Czuprysnki, and I'm a senior enterprise data architect for Viscosity North America. And I believe that title, Senior Enterprise Data Architect, is something that you're going to start seeing as a replacement for database architect or Oracle DBA in the future. So just to give you the background on that particular title, so that's why I call myself that. I don't need to waste any time on this slide because I've already presented that, or Morgan's already presented on my deck. And here's my contact information. Feel free to reach out to me. I'm not going to be answering anything right now, but feel free to go ahead and put anything in the chat, and then I will go ahead and answer at the end of this presentation. But there's my contact information. Let's jump right in. If you attended last week's or 2 weeks ago presentation on 18C, 19C, 12CR2, what you saw was this slide. And what we've got here is essentially a listing of all the different features of these different releases. Let me just take a checkpoint here. Is everybody hearing me okay without an echo? Morgan, is it good?
Yep, you're good.
Good. Okay. let me just turn up, I know what's going on. Let me turn off my PC echo here. 10 seconds. I can figure out where that is. How's that? Still got a little bit of echo maybe. That's okay. We'll keep going. Okay, good. That's a little bit less of a pain. There we go. That's perfect. Okay, there we go. Okay, it's just a little hard for me to do that with the echo. We're fine. So anyway, back to what we're talking. So 12CR2 had a lot of really great features, multi-tenancy, partitioning. Both of those became much more mature in that release. Database in memory became more mature. Now we can do it inside Active Data Guard. And finally, partition external tables, because that feature really brought into focus the enterprise data architect role, because now you can actually access data in many different formats, including stuff outside of your own hardware. So for example, you could access HDFS or Hive or JSON documents from outside your current environment. 18C brought in a lot of really great stuff, especially automatic in-memory external tables. I went into much more detail on PDB snapshot carousel in the last presentation. Didn't talk much about PTFs in the last presentation, but they were definitely in play there. So something interesting to take a look at when you get some time. 19C offers now automatic indexing, AIC. And that's probably the most compelling new feature. But let's remember that's only really available with trying to think of the right tool, autonomous database, specifically ATP. So when people talk to me about autonomous database, they go, is it 18C, 19C, 12C? My answer is yes. Someone once asked a politician, what's your favorite color? And the politician said, plaid, right? Because autonomous database is really a service, right? It's not specific to 12C, 18C, 19C. 19C also has this feature called SQL tuning, real-time SQL tuning, which really means that the optimizer can react in real time. It's not just like adaptive cursor sharing other things. It's the ability to actually tune SQL in real time as they're executing. A really neat feature, by the way, the dynamic, I'm sorry, scratch that, data guard DML redirection. So, for example, if you accidentally executed a DML statement, an update, for example, against a data guard, active data guard physical standby, Oracle would go, hey, you know what? Obviously, hey, Jerry, you're not thinking about this correctly. You can't do DML against your, you can't do a DML directly against a physical standby. I'll redirect it over to the primary database itself. Of course, that will generate redo. That comes through redo transport, and the active data guard physical standby stays updated. That's just mind-blowing how cool that is. I talked a little bit at the end of that webinar about hybrid partition tables, HIPES. There's a good acronym, huh? But hybrid partition tables actually lets you combine for the first time inside DDL for a table, data that's stored within your RDBMS and an external table format. So that could be Hive, that could be HDFS, JSON document, CSV, some other type of delimited table, but with one DDL statement. Just started experimenting with that a little bit. It's interesting what you can do with that. And I'm looking forward to working at that a lot more with 19C as I participate in the beta testing program. But that kind of summarizes what we talked about in the last webinar. By the way, just wanted to share this with you. I have this out here as a link. If you want to actually see what we did last 2 weeks ago, last month, actually, you can go to our YouTube channel and That webinar has been edited and recorded, and you can take a look at it. I can't guarantee you what's going to be on the right-hand side for what YouTube recommends. As you can see, I have 11 worst Soviet aircraft. I don't know why that's popping up there, but you may have some different links. I don't want to see your Google page. Anyway, but certainly, you can go out there and take a look at last week's presentation. Let me resume with what we were talking about here. And what we said at the end of that presentation was, you know what? ODA is an extremely powerful partner to take advantage of 12CR2 and beyond. Remember, 19C is merely the terminal release of 12CR2, but it's an amazing platform to be able to take advantage of this. Remember, you've got 3 flavors, small, medium, up at the top here, and if you will, large, or HA, right? And I've got the picture of it right here. How much storage do you have? 64 terabytes if double mirrored, with 2 trays of SSDs. 43 terabytes, only 43 terabytes if it's triple mirrored. And the funny thing about this is that I had a conference call with one of our clients, and one of the things that we talked about was how do you would make that transition to Exadata or to cloud, right? And he says, I've got this 18 terabyte data warehouse. Where could I possibly put it to evaluate how it might perform with Exadata, but not using Exadata or even Exadata in the cloud? And I went, ODA, this would be a great way to take advantage of it, especially for what we're going to talk about in the second half of this presentation, hybrid columnar compression. Starting in 18.2 Oracle Database, you can now leverage hybrid columnar compression on ODAs. Now, I'm going to talk to you a little about some of the limits there of that, but it's an intriguing possibility, quite an intriguing possibility. So let's move on to some other options for OAKS 7 HA. First off, one of the things to realize, a lot of shops use virtualization, but you can also use bare metal licensing for ODA X7-2. So here's the cool thing. You can start with only a couple of cores per node. Remember, the whole idea of the HA platform is rack. So essentially, when ODA first came out, it was marketed as rack in a box, right? High availability for a relatively good-sized database. As we saw, right, you can go 42 terabytes, I think it was, 43 terabytes roughly, of storage, even if it's just triple mirrored. That's a pretty prolific sized amount of storage. But what if you want to take advantage of the licensing features for X7-2? You can start with 4 cores, license your database at only 4 cores, assuming you're doing rack, and then ramp up to either 8 for each node if you're doing this as only a single node database, right? But if you're doing rack, you can go from 4 to 16 to 32 to 42, a total of 72 cores across both nodes. That's a lot of power. And let's remember that this is the same hardware that's being used on Exadata. Not all the same features, not the same storage cell features, but same hardware. And if you're interested on, so how good is performance? Well, it's pretty gosh darn good. This is actually a performance test that Oracle did with Swingbench. I'm looking at finding the actual white paper for this. It's quite intriguing. I haven't located it yet, but I know it's out there. Take a look at the transaction performance. OLTP, 36K TPS, 32K plus reports running in 30 minutes. Now, again, how big are those reports? How long do they run each? Not so much important as I can really bang hard on this hardware and it'll respond quite well. How well? We're looking for IOPS in megabytes per second, right? So again, megabytes per second would be more applicable to a DSS workload, but for IOPS, right, we're talking that's for OLTP. That is 2.25 million transactions per second, essentially. Single block reads if we use IOPS, right? Resource consumption, that's pretty impressive. You never went over 62% available capacity for OLTP, 75% for DSS workload, right? Not too bad for that. And IO capacity, based on their tests, was never saturated. I'd love to run some of the tests we're building for an Exadata environment against this environment. I'm hoping we're going to have a chance to play against the next release of ODA, which is X8. It's coming soon. We don't know when exactly, but we are planning a webinar specifically on ODA X8-2 in the next few weeks, as soon as that information is available. Now, you're going, how could I take advantage of this? Well, let me just give you 4 use cases. First off, let's talk about virtualization, right? We all know that Oracle controls its licensing pretty strictly, and it's, of course, going to license its virtual machine, its OVM, much more aggressively than other hypervisors. So we've had clients come to us and go, the licensing costs per core of Oracle on, for example, VMware are killing us. So how are we going to take advantage of this, you know? And hey, first off, remember, licensing, Larry makes those decisions. Mr. Ellison is the one that makes those decisions. I have no control over that, okay? But you can get excellent performance with OVM on an ODA, right? Because let's be honest, when it really comes down to it, yeah, you know, cost containment for particular license features are important. When I'm a DBA or a SETA, if you will, right, an EDA, I am not the CFO of the company. I look at license features as a necessary evil. I spend more of my time now going, dear CFO, dear CIO, here's why I need this particular license feature. This is what it'll do for my system, right? So again, even though Einstein finally discovered that time is money, as his famous cartoon shows, I'm still focused on getting the most I can out of a machine. And again, if it's leveraging OVM instead of some other hypervisor, this is one way I can take advantage of it. Here's another thing that's relatively new. This was introduced, I'm pretty sure, in X7. It might have been there in a primitive form in X6. But you may not know this. Did you know you can actually hard partition an OVM? Scratch that, an ODA with OVM, just like you can with an Exadata. So a situation might be your organization has both Windows platforms, maybe you're running Windows 10 Server, but also Linux, or maybe even Solaris x86, right? Well, that'll work in this particular environment, right? The situation might be your Linux ODA partitions may need more resources than your Windows environment or another environment that's a development environment. So you can leverage hard partitioning to guarantee SLAs for production, if you will, or maybe even a robust test environment versus a development environment, right? And remember, this is essentially Exadata hardware, and you can get extremely close to the Exadata footprint for performance. Which takes us to yet another case. Use case number 3, I call this the jack-in-the-box, or whatever you like in a box application solution. I have many clients that use Enterprise Business Suite, and they need a robust platform. You need one with a ton of CPUs, like 72, and up to 42 terabytes of triple mirrored storage. That's a pretty robust platform. And as compared to running the cost of running this on VMware, this may be a very compelling case for especially EBS, but don't forget there's other things. PeopleSoft, JDE, a lot of our education, higher education universities run Banner. Why not run this in a box, right? And transform that little scary clown there into the nice, friendly, happy clown that Jack in the Box represents. Here's another one. A lot of shops I know are running Exadata. They spent quite a bit of money on at least a quarter rack or a half rack for their particular needs. And then they go, well, how can I test my applications and know how they're going to work inside Exadata? How about not? How about instead of buying an eighth rack, simply leveraging an ODA? Almost the same hardware, except essentially, yes, exactly the same hardware. I should say almost the same software. The only real difference is the storage cell software not being on the ODA. If I license this as bare metal, I've got essentially the same resources, except again, storage cell resources, which are going to prove out to be probably not that significant when we start talking about another set of features, especially HCC, which is coming up in the second half of this presentation. So why not just license an ODA, which gives me 90% of what I need for development, for the resources for development, for example, or for even quality assurance testing. Again, the guarantee would be that because I'm running on the same hardware, instead of running on, say, IBM Power or Hitachi or whatever else, right? Sun, why not just go ahead and run on ODA? I'm almost as close to Exadata. It's as close as I'm going to get, but not at the same cost as, say, an eighth rack. And by the way, if you think we're kidding, we have proof. If you go out to our website, viscosity.com/ODA, here are just six of the use cases that are similar to the ones I've just presented. Perhaps you're a healthcare provider. We have 2 different healthcare providers alone just in our use cases that we've case studies that we have available, right? And we're going to be adding more out here. These range from all the way from a complete implementation on ODA to simply the last one I think in the list, if I remember correctly, is we simply helped the DBAs at this particular organization learn how to use their ODAs better. So we can hit to any field, using a baseball metaphor, of course, but that's the idea here. We can help you out with this. And now we're going to move on to the second part, and ideally we're 23 minutes into this, so we're going to go 45 minutes into our presentation here. What I want to talk about is one of the really cool features, hybrid columnar compression, that starting with 18.2 database, right? So 18C, release 2, or RUR2, if you will, you can now leverage hybrid columnar compression. Now, who cares? Storage is cheap, and as Dilbert predicted quite a time ago, we're going to run out of disk space. We're going to run out of spinning Rust, and we'll all have to move into becoming mole people, and Wally's already 2/3 of the way there. And as Wally replied, oh, well, a software solution, how about HCC? Okay, we're stealing that example, but you get the idea. This is one of the situations where actually software is a solution instead of hardware, right? Have you heard the term Kiwi, killing it with iron? How about not killing it with spinning Rust? How about not killing it with storage at all? Because as Tom Kite said many years ago, the fastest way to do something in Oracle is to not do it. As my colleague and fellow ACE director Tim Gorman says when it comes down to partitioning, the fastest way to access a table that's partitioned and get the data out of it is by accessing only the partitions you need to. So what if we could leverage a software solution to make physical I/O significantly reduced, unless we have to physically do it, no pun intended, and make it run faster? That's what HCC is all about. So this is a little bit of an older slide from Oracle, but here's their exact examples, right? Up to 50x space compression, right? Space reduction. Is that going to vary depending on your data? Oh yeah, and again, a good example coming up here. real live examples directly against an Exadata environment. You might see 50x space reduction. You might only see 5x reduction, but that's still 400% reduction. In their case here, they're showing a 94% reduction, in storage from 735 gigabytes to 38 gigabytes. But here's where it really makes a difference. Because you're doing less physical I/O, because you're reading compressed data, you are now going to see queries, in their example, running 8 times faster. Now, don't expect any kudos from your users. It's supposed to be faster, right? That's what they expect. They don't ever come along and thank you, do they? Right? If it's run faster, it's starting running slower, then you hear about it, right? But the idea behind this is, especially for data warehousing, you're going to see significant performance improvements because, simply put, you're going to read a lot less data. Are you going to see a big impact for OLTP? No. No, you still have to insert rows, even if you do bulk collect, row by row or block by block. Right? We're not talking necessarily about data loading. We're not going to see necessarily any advantage here. But for query, once it's loaded, you're going to see a significant advantage. And it's not unusual, depending on the type of query mode or archival mode that you use. There are 2 different values. There's a low and high for each. I'm going to show you examples of what that compression looks like, right? But for query mode, you might see between 5x and 15x. For archival, you might see 15x to 50x. Okay? And it's going to depend on the data types that you have inside each table, right? Obviously, you have a varchar 2 4000 column that's not always filled in completely. There's a lot more opportunity to compress with the different compression algorithms that are built into HCC. And by the way, HCC is designed as an on-disk or spinning rust, compression mechanism. There are over 20 separate algorithms built into HCC to make compression as compressed tightly as possible. And by the way, yeah, it's compressed for reading, but guess what? That means when you go to back up those blocks, backups are faster. Restore and recovery is faster. Caching is more efficient. So is database reorganization. So is database cloning, especially if you're doing PDB clone, right? Because your data files are smaller. You can squeeze a lot more into a smaller space. And so let's take an example here. Let's pretend we've got a table that's got 10 terabytes worth of data. If that table's not partitioned and it's indexed, but I can't take advantage of the index because I've gone after as little as 6% or more of the data. Remember, the optimizer may throw up its hands as little as 5% or more of the data is going to be retrieved via index. It'll just go table scan, faster view, multi-block access, right? So if I'm using non-compressed data, sorry, 10 terabytes has got to come across over to the database buffer cache. But wait, what if I had used HCC and just got 10x compression? Not unusual, especially if I have significant enough amount of blob or clob or varchar data, right? I might be able to get 90%, 9x, or I should say 10x compression in this case. And that means instead of pulling across 10 terabytes across the storage network, I'm only going to pull 1 terabyte. But wait, what if I'm going after the most recent data and that table is actually partitioned? Because I can do partition pruning, I'm only going to pull in 1% of that 10 terabytes. If you look at it from a block by block perspective, right? And now remember, it's running on an ODA with 72 cores at its maximum size, right? Maximum configuration. Yes, I do have to decompress the data, and that's going to take more CPU. I'm only going to have to do that one time. Once I pulled it into my database buffer cache, it's going to be stored inside the buffer cache in compressed mode. And that leads to sub-second response time. And remember, backups are smaller. It means restores are smaller as well and faster. So here's some actual code. You didn't expect code today, did you? Yes. So I created this table. It's a table I've been using for in-memory external tables and hybrid partition tables experimentation. And note this one's a little different from many tables. First of all, it's rather small, 5 columns, and they're all numeric essentially, right? Timestamps are numbers, aren't they? They're simply a number of ticks. So how much compression am I going to get out of this with HCC? Probably not that much. Why? Ever compress pictures? Right? Do you ever have anybody do that? Well, zip up all your images. How much compression do you expect out of that? Right? You zip or RAR or something like that. Usually you get very little bit of compression. Maybe 1x, 2x compression, right? So I'm not expecting a lot of compression here. Second point, the oldest partition actually has data going back, I think, if I remember correctly, to 1998. There's a boatload of data in that very first partition, and it's old. How often do you think I'm querying against it? This is a perfect example of data that's being retained, for example, for regulatory purposes. Think about healthcare data, right? Okay, I'm 61, 62 this year. Man, I'm feeling it. Let me tell you this. 40 is the new 30, 50 is the new 40, 60 still the bleeping 60, okay? I just want to tell you that when you get there. Just remember that. Okay, the 2013 partition has 3 years worth of data. The 2015 partition, 2 years worth of data. The 2016 partition, 1 year. The 2017 partition, I should say, 1 year. The 2018, maybe one's got a couple of months or a couple of quarters, right? Why? Because we haven't got all the data yet. So that particular partition, 2018, see, I'm going to probably be doing DML against it, maybe some additional bulk loads against it. Does it make sense to even compress that one? No. I load my data with SQL Loader. I create a primary key index, and now I'm ready to start querying it. But wait, I'm going to apply some compression against this. How? By HCC. So the oldest compression, or partition, I should say, CCR oldest, I'm going to use the most robust compression, archive high. For the 2013 partition, which has about 3 years worth of data, I'm going to use the second highest compression, but it's still archive compression. For the 2015 partition, which has 2 years worth of data, which I'm going to hit occasionally, right? That's only 4 years ago, if you count 2019 as current data. I'm going to compress it for query high. You'll see that generally archive low and query high compression are almost equivalent. Right? It's 2 different sets of compression algorithms, but one is aimed at compressing for query capabilities, one for archiving, right? So you'll typically see a bit more CPU expended to do the decompression for archive low than you will for query high. And finally, for 2016, I'm going to go ahead and use query low, the default compression algorithm. And what about 2017? I might still be doing some DML against that one, so I'm going to enable not HCC compression, standard row compression, but using the advanced, or what we used to call OLTP compression. And by the way, what about 2018 data? I can either leave it uncompressed or actually use row store compress advanced. Some studies that Oracle's done, haven't seen any lately ones, have said that compress advanced, what we used to call OLTP compression, actually benefits DML in many cases. Go figure. And if you think about it, it actually has to do more with how it moves the high watermark of that particular segment and everything else like that. But just wanted to make a point there. You can mix and match this or simply not compress a particular partition. Well, how the heck do I know when to compress these things? Don't worry about it. Let the database do it for you. Did you know you could do this? With information lifecycle management, which has been around since 12.101, with something called automatic data optimization, you can actually build ILM ADO policies that says, in the case of the 2018 partition, hey, when 180 days of no DML have occurred, in other words, no DML for 180 days, snap, I would like you to now compress this. How? Using advanced compression. So again, this segment could be left, this partition could be left with no compression until nobody's applied any DML against it for 180 days. How about for 2017? Hey, you know what? Change its compression from compressed advanced for rows, right? Advanced compression, to query low compression after 300 days of no one touching it via query or via DML. Hey, so what happens at day 298 when somebody touches it? Boop, the timer gets reset. It's kind of like, remember on The Simpsons, whenever they have an accident and, in the nuclear plants, right? And they say, number of days since last accident, 0, right? And usually in Springfield, it only 3 days anyway, because Homer Simpson works that way. So here's another example, right? How about for the 2013 partition? Hey, I want to compress after 600 days of no access. And after, for the 2011 partition, right, which has got 3 years worth of data, take that from archive low to archive high compression after 900 days of no access. Might have no access at all. And again, remember, if 880, day 898, somebody touches it, boop, counter gets reset. By the way, how can I test this? I can't waste 900 days. There's a way to actually have your ILM policies treat days as seconds. Really good for boring days. No, seriously, you can actually do this. I've got a presentation out on my blog. If you're interested, send me an email or send Morgan an email at viscosityna, hello@viscosityna.com, and I'll be happy to send you a link to that, right? Because there's a trick that you can use. You don't want to forget to turn it back on, turn it back to 900 days instead of 900 seconds, but you can actually do that. Remember, 900 seconds is 15 minutes. Well, how will I know how much compression to get? That's a great question. There's a great little routine called DBMS compression. And I can use the get compression ratio procedure for a particular partition. So here I'm taking my oldest partition, CCR oldest, and I'm saying, hey, if I use comp query low, the default compression, and if I said, look at all data in that segment. By the way, normally the default is 1 million rows. It performs an estimate based on that. But if I use dbms compression.comp ratio all rows, it will use every single row in that partition. And I can actually calculate the number of blocks, but also the number of rows compressed versus uncompressed. And so here's what the results are for that particular partition. Almost 70 million rows, compressed query low. Look at this, 2.3x. Well, yeah, it's compressed query low. I'm not expecting a lot. And don't forget, it's mainly numbers. Remember, compressing pictures? What do you expect? Not a lot. But here's some interesting results. I ran this for that same partition using all 4 different compression methodologies. And notice I went from 239.4, 2.4x compression roughly to almost 5x compression when I applied archive high for this particular 70 million row roughly partition. Okay. And again, remember, these are mainly numbers. How much compression do you really expect to get, right? Not a lot, but you still got almost 5x here. So here's what it really makes a difference. I'm going to take a look at my warm partition, the 2017 data, and this is before or 0, no compression at all, versus after compression. Remember, this one has query low compression. Look at the impact. I went from 3 seconds to access this to about 1.5 seconds. That's a 50% performance improvement, right? Now, don't expect your user to call you up and go, nice job. You're not going to get that, right? Because it should have already been running faster, right? That's their attitude. But look, why is it running faster? I cut physical reads by almost 4,000, just over 4,000. different physical reads. And look, optimizer cost is reflecting that, 1426 versus 1617. Here's the cool partition. This partition's cool. Yeah, it went from 1.72 seconds to 1.94 seconds. Yeah, I made this a fair test. This is not counting the next set of reads, which would be directly against the database buffer cache. This is the non-warmed database buffer cache. So yeah, it takes a little bit more time to decompress query high. But the next time I go after it, I'm going to be doing a lot less physical access. In fact, I'm going to be doing no physical access, providing that this fits inside the database buffer cache. And not only that, how many consistent gets am I going to be doing? About half as many. And notice the optimizer cost is reflecting this. And finally, for the ice cold partition, right? This is the coldest one, CCR oldest. I should have called it CCR coldest, right? But take a look at this. This is, by the way, notice I've pulled 9 months worth of data, so about the same amount of rows in each case, right? Because the way I generated my test data was exactly the same number of rows, basically, per each customer. So it's roughly the same amount of data if I go after 9 months worth of data. The execution time for non-warmed buffer cache went from 33 seconds roughly to 48.5 seconds roughly. It's taken longer for the first read, not afterwards, because notice I've decreased my physical reads by almost 200,000. And the optimizer cost reflects that, right? It's dropped by half. So what do you think is going to happen when I do a consistent get of that block, which is compressed inside the database buffer cache? The performance is going to even be better. So there's an example of what HCC brings to you. And here's one of the really cool things about working with Viscosity. First off, we have our own landing page for everything ODA. A lot of shops don't have that. And another thing a lot of shops don't have is 6 Oracle ACEs, 5 of them ACE directors. May have mentioned this in the last time I talked to you all, but what that means is that you've got 5 ACE directors focused specifically on Oracle database technology, which means 25 to 30% of all the ACE directors in North America focused on database technology in your corner. And I've worked for Oracle partners for off and on for the past 7 years. One of the things I like about Viscosity is we know more about Oracle than Oracle does. And many of the folks at Oracle will go, here, here. That's absolutely true. When you have the person that wrote ASM while they worked at Oracle on your team, you understand storage, you understand database recovery features, you understand Data Garden Golden Gate. And here's the second advantage. You're not Oracle. That means we talk to you from the way you see problems as DBAs, as storage administrators, as DevOps developers, as enterprise data architects. That's one of the real advantages of working with a platinum partner like Viscosity. And again, I'm speaking as someone that just recently joined the company. The amount of talent that this organization that can help you solve problems is mind-blowing. I'm speaking as someone that saw Viscosity from the outside for 5 years and actually either partnered or competed against them. Just want to let you know that. Here's some other information. Actually, I grabbed that fact sheet on the HA platform earlier this morning to look up a few numbers. There's a couple of other really great little links out here to some other articles, including some information of licensing databases and other database features on the ODA, and some other more recent information directly from Oracle, their blog series on ODAs. And with that, I believe I'm right at my time here. Oh, I love it when a plan comes together. Time for you to ask me questions. And Morgan, I'm going to turn this back over to you.
Hi, yeah, we do have a couple questions. One of the questions is HCC available in X6-2 HA?
I am not 100% sure on that. I would have to double check on that. The main thing is you have to be on at least 18.2 database to take advantage of HCC. I'll take an action item. Do us a favor, send us an email back. We'll send you back an answer on X6-2. I'm pretty sure it's X7-2 the first time it was available. But I'll find out if it's possible to refresh your ODA environment so that you can take advantage of 18.2. Fair enough?
That's perfect. Well, if anyone else has any other questions, feel free to email Jim, myself, or hello@viscosityna.com. Thank you all for joining. We will make the presentation available to you after we edit that. So I'll get that out to you guys soon. But thanks, Jim. That was an awesome presentation, and thank you everyone for joining.
And one other thing, just remind you, if you're from the Chicagoland area, next Thursday, we have an all-day session at the Northbrook Oracle office. It's an Apex-focused technical day. I'm going to be presenting there, but from the perspective of a DevOps DBA and an old school DBA learning to become a new school DBA. And breakfast and lunch is free. If you're there, it'd be great to see you. Otherwise, I'll see you, I hope, at, let's see what's coming up. We have the NCLUG? No, I'm sorry. The Cleveland event's coming up. I'm trying to remember the name of it.
Clock.
Clock. Right.
Yeah.
Right. Yes, exactly. Thank you. Yeah, so we'll see you then.
All right. Thanks, Jim.
See you guys. Have a great day. Bye-bye.